Hello, in this video we are going to learn about the laws of motion. Newton's laws of motion, relations between the forces acting on a body and the motion of the body, first formulated by the English physicist and mathematician Sir Isaac Newton. Let's go to the first law of motion. The first law says that an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same direction and speed. Motion cannot change without any unbalanced force acting. If nothing is happening to you and nothing does happen, you will never go anywhere. If you're going in a specific direction, unless something's happened to you, you will always go in that direction forever, like the ball in the picture. Let's go to the second law of motion. The second law of motion describes what happens to a massive body when it is acted upon by an external force. It states the force acting on an object is equal to the mass of that object times its acceleration. This is written in mathematical form as F equals ma, where F is force, m is mass, and a is acceleration. The second law shows that if you exert the same force on two objects of different mass, you will get different accelerations, like the one in the picture. The effect on the smaller mass will be greater. The effect of a 10 Newton force on a baseball would be much greater than the same force acting on a truck. The difference in effect is entirely due to the difference in their masses. Let's go to the third law of motion. The third law says that for every action there is an equal and opposite reaction. That is, for every force there is an equal and opposite force. Forces are found in pairs. Think about the time you sit in a chair. Your body exerts a force downward, and the chair needs to exert an equal force upward, or the chair will collapse. Acting forces encounter other forces in the opposite direction. There's also the example of shooting a cannonball. When cannonball is fired through the air, the, the cannon is pushed backward. The force pushing the ball out was equal to the force pushing the cannon back. But the effect on the cannon is less noticeable because it has a much larger mass. I hope this video was helpful. Thank you for watching.